Hello and welcome to another video in the series on the free Havok SDK. In this video we're going to be talking about the demo framework, what exactly it is, and how we can use it to create a simple demo. So what exactly is the motivation behind the demo framework? Well, it's provided as a way for you to quickly and easily test out the features of Havok, in this case the animation and physics systems, in a way that is similar to how most games would be implemented. In fact, most of the demos that come with the Havok SDK use this demo framework, which means not only is it feature complete, but it's also very well tested. That being said, however, it is not intended as a commercial graphics or game engine, but you can use this demo framework to create really complicated and interesting demos and games. So what modules are actually provided in the Havok SDK? So the Havok SDK has HK base, and there's also the features that are implemented in the demo framework itself. And here are some of them. Memory management, file system for reading and writing files, serialization so that you can save off Havok objects to and from disk, rendering, camera support, input handling for mouse, keyboard, or even gamepad, multi-threading, a very extensive math library, and basic sound support. So, given all of these modules, it's pretty much all you need to get up and running very, very easily. So let's go ahead and talk about what the base game execution flow would look like for a particular demo in the demo framework. Well, you start out by initializing all of your modules, like your memory system, your file system, and then you do any preliminary loading that you need before the actual game loop starts. And the game loop is the main thing. That will loop indefinitely until the user says, I'm done, or they quit out of the window, or what have you. And once the game loop is finished, you go to the unloading stage, deleting any files that you may have loaded before the game loop, or just basic cleanup. And then, well, actual cleanup would be where system modules are uninitialized, graphics system is shut down, and so on. And the more important part of this is the game loop. So what exactly would this look like? And this is an extreme oversimplification, and different games would implement this in different ways. But basically what you have is you start off with the game loop by handling input, seeing what the user has pressed, and then you can update the AI, update the animation system, update the physics system, and then finally play sound effects, and then finally render all of that to the screen. So again, this is a very oversimplification, but it's a good idea to keep this game loop and this overall game execution flow in mind as we go forward. So how exactly is this implemented in the demo framework? Well, we have one base class called HKDemo, and this is what all demos inherit off of in the demo framework. And it's an abstract class, so you can actually use HKDemo. You actually have to inherit off of it and implement certain functions before you can use it. And to get the game execution flow that we saw in the previous slide, HK default demo is provided for you, and that does most of the work you need. But it doesn't do all the work in case you want to have physics in your game, for example. If you want physics in your demo, then you have to use HK default physics demo, which actually steps the physics. In other words, it updates all the physics objects in the world and actually handles collisions and so on. So if you want physics in your demo, inherit from HK default physics demo. For example, wheel demo that's provided with the SDK inherits off of HK default physics demo and just provides the functions necessary for the wheel demo, creating the physics objects, handling any user input, and so on. On the other end of the spectrum, we have menu demo, and this is sort of the overarching main demo that's executed by default when you start the demos project. And this is simply a demo that provides an interface to all the other demos in the project. So if you've run the demos project already, it provides a little menu, and you can scroll through and select individual demos, restart them, play them again. That's all implemented in menu demo. And since it doesn't have to handle any physics stepping or animation systems, it simply inherits off of HK default demo. So how is this actually implemented? Well, the initialization, everything starts out in framework main. And then from framework main, it initializes the base system, and then it initializes the renderer and the environment. Environment here being everything from the window to the command line arguments and so on. And then it calls framework start demo, and depending on whether or not you passed anything on the command line, by default, if you didn't pass anything, it will start menu demo. Otherwise, if you pass something in on the command line, it may start that demo specifically. So it creates a new demo, and then each demo is responsible to set up the cameras and set up the graphics. And once initialization done, we actually start the game loop. And this is very simple. It does framework step, which handles some internal updating, and then it calls each the currently active demo's step demo function, where you could be handling input processing from the user, or maybe you want to add forces or what have you. All of that would be done in step demo, and that loops indefinitely until something happens as described before. And finally, you want to unload and clean up, which of course you'll want to delete your demo, basically do everything in the opposite order that you did in the initialization loading step. So you delete the demo, quit the renderer and environment, doing any cleanup work there, and finally quitting the base system, so uninitializing the memory system, I/O, and so on. Alright, so given this, let's go ahead and switch over to the code and see exactly how these pieces are implemented. So here we are in hkdemoframework.cpp, and that's under demo, demos, demo common, demo framework. We have framework main, which, as we said before, is where everything begins. So we start out by initializing the base system, again, the memory system, file system, and so on. And then we come down in here, initialize the renderer and the environment, and then once we do that, we go ahead and start the demo. And now that we have our demo pointer, we start looping, and this just keeps looping and looping until the window no longer says continue, or the framework step returns stop me or restart me, and it keeps going and going like this. And in each step it calls framework step, and framework step, if we dig into this, primarily, it does other things as well, but primarily handles step demo. And that's the function that is virtual that most demos will actually override. So after this loop is over, it deletes the demo, quits the render and environment, and then calls framework quit base system. And that's all there is to it. So as you can see, it's pretty straightforward. There's not a whole lot here. If you want to dig into it more, you definitely can. But this is all you need to get up and running. So now let's take a look at how easy it is to make one of these demos. I've already implemented a very simple demo offline. I'm going to show you how to get it into the demos project, compiling and running, and show you how the pieces all fit together. So let's switch over into Windows Explorer here. And here in the base folder of the Havok SDK, let's go under Demo, Demos, and under Showcase, we're going to create a new demo here. Let me just go over into my pre-existing simple demo here, and I have a source and a header file. Let me go ahead and copy these two files, and over in my Havok SDK, let me create a simple folder here and paste those two files in here. Now let's switch over to Visual Studio. And here under Demos, Showcase, let's go ahead and add a new filter, and we'll call this Simple. And let's go back here and drag and drop these two files into our project. Now if I compile this, let's go ahead and take a look at what this looks like before we talk about it. Alright, here we go. So here we are in Menu Demo. Let's go down to Showcase where we place the demo. Press right to go into it, go down, and press Enter to start the demo. So here we are, a simple platform box on the bottom, and if we press 1, boom, a new box is created. And we can keep pressing this, and new boxes will keep getting created. Very simple demo, but a good starting point to see exactly what it takes to create a demo. So let's go ahead and exit this out and show you how simple it really is. So let's go back to the Solution Explorer and let's look at the header file first. And this is it. All we do is include the HK default physics demo header file and create a new class that inherits from HK default physics demo. Again, we inherit from physics demo here because we actually have physics objects in our scene and want the physics to actually get updated every frame. One important note here is that we use this macro here to hook into the Havok memory system. We also need to implement the constructor, and we override the step demo function, which is where we're going to be handling the user pressing the 1 key and spawning a new cube. So let's look at how this is implemented. Let's go into the source file here, and right in the constructor, the first thing we do is set up the camera, and it's a simple look at camera that's pointing down on our plane. We create the world, which we'll look at in more detail in later videos. We create the base platform, and then here in step demo we see if the 1 key was pressed, and if it was, we go ahead and create a new box and place it in our scene. And then at the very end we actually call the base classes the physics demos step demo function, which handles, you guessed it, stepping the physics system and other things as well, but that's the main thing that we need here. So that's it. That's all there is to it. Obviously, there's details on all of these function calls that we'll look at in the future, but it's very, very simple to get up and running with a simple demo. And finally, before we wrap this up, the one thing that gets our demo to be visible by menu demo is this macro called HK declare demo. And all you need to do is pass in the name of the demo class, the type of the demo that you have, and this is used for when you want to do test cases. Because we're specifying demo type physics, we have benchmark systems put in place so that all physics related demos can be run at the same time. We have a name for our demo, friendly name for our demo, and a help string that's displayed at the top, and that's just simple demo. It shows how easy it is to create a demo. And I certainly hope you are convinced that it is easy, and start getting in there and playing with this, because there's a lot to explore. There's a lot of modules that are available, so just start playing with it and see what you can do. Thank you.